Hello students, welcome to Anne's classes. Let's do rational numbers exercise 1A. This is on page number 9 and we are doing question 5. Let's read this. For each set of rational numbers given below, we've been given a set of rational numbers. Verify the associative property of addition of rational numbers. Now this is the associative property of addition of rational numbers. That is, if you have three rational numbers like this, you can group them in different ways and the answer will still be the same. Now suppose I take this. Now suppose I take simple terms like A plus B plus C, and this is equal to A plus B plus C. Now even if my grouping is different, that is, if I group it like this, A plus and the sum of B and C, or A plus B, the sum of A and B plus C, my answer is still going to be equal to each other. So this is called the associative property of addition. And we have to verify this property in these sets of rational numbers that's given to us. This is the first set of rational numbers given to us. We are going to verify the associative property. So we're going to put it in this form. And then we're going to have a left hand side and a right hand side. And we're going to prove that even if you change the order of the groups, your answer is still going to be the same. So the first thing we're going to do is we're going to write it in this form. We're going to write these three rational numbers in this form. So let's write that. So this will be 1 by 2 plus 2 by 3 plus minus 1 by 6. This is equal to, again write the same 3, 1 by 2 plus 2 by 3 plus minus 1 by 6. Now we're going to show the groups. So here let's take the second and the third and make it one group. Here we'll take the first and the second and make it a group. Now we're going to work this out and see if this is true. Associative property is verified here. Whether the answer that you get here is going to be the same as the answer that you get here. So this is your left hand side and this is your right hand side. At the end, left hand side should be equal to the right hand side. So let's begin with the left hand side. LHS means left hand side. So let's do that. So here we're going to take only this much. So let's do that. So that is 1 by 2 plus. Now what is within brackets? We're going to work that out. So as you can see, this is 2 by 3 plus minus 1 by 6. The denominators are different. That means we must find the LCM of the denominators 3 and 6. So let's find the LCM of the denominators 3 and 6. Starting with 3, 1, 3 2s are 6. Now you can continue with 2, 1 and 1. So what is the LCM? LCM is 3 into 2, which is 6. So we've got our LCM. We're going to use that as the common denominator, 6. Now there are two ways of finding the numerators. You can use any one way that is easier for you. So 3 has now become 6. So 3 2s are 6. So 2 2s will be 4. Let's go to the second one. The second rational number here is minus 1 by 6. Look at the denominator 6. 6 into 1 is 6 itself. It's the same, isn't it? So if this is the same, then the numerator also will be the same. So minus 1 into 1 is minus 1. So now we have our grouping. We have done it this way. Now let's continue. 1 by 2 plus, let's work out what's within brackets now. 4 minus 1 by 6. Close brackets. Then it becomes 1 by 2 plus 4 minus 1 is 3, 3 by 6. Now you can continue this way itself, or you can even reduce this to the lowest term. So let's try and reduce it. 3 1s are 3, 3 2s are 6. So now this has become 1 by 2 plus 1 by 2. Okay, so denominators are the same. So we write that as the LCM. If denominators are the same, numerators also will be the same, 1 plus 1. So 1 plus 1 is 2, denominator is 2, 2 by 2 is 1. So when we worked out the left hand side, we got 1 as our answer. Now let's go to the right hand side. This is the right hand side. Let's work out the right hand side. So on the right hand side, we have this within brackets. That means to simplify this, we have to find the LCM of 2 and 3, which we have already found here, and it's found to be 6. So let's write that down. So that will be Here denominator is 6. Okay. So that is now the LCM, which is the common denominator for both these. Now 2 into what is 6? 2 into 3. So if we multiply this by 3, we have to multiply this also by 3. 1 into 3 is 3 plus, now go to the second rational number, 2 by 3. 3 into what is 6? 3 2s are 6. So multiply this by 2, multiply this also by 2. 2 2s are 4. Then we write the rest as it is, that is plus minus 1 by 6. So this will continue. 3 plus 4 is 7. 7 by 6 plus minus 1 by 6. So here the denominators are the same. So we write that as the LCM. And if the denominators are the same, we write the same numerators also. So 7 plus minus 1. So 7 plus minus 1 means 7 minus 1 by 6. 7 minus 1 by 6 is 7 minus 1 is 6. 6 by 6. 6 by 6 is equal to 1. So on the right hand side, when you work it out, what answer do you get? You get 1. So what do you see? The left hand side is 1. The right hand side is also 1. That means the left hand side is equal to the right hand side. So now we can say left hand side is equal to the right hand side, hence verified. We have verified the associative property of addition for this set of rational numbers. So this is how you have to do. You have to first put it in the form of the associative property of addition and then prove that both sides are equal. Question 2. So here also we have this. So let's put this in the form of the associative property. So let's write that. We'll write all three rational numbers minus 2 by 5 plus 4 by 15 plus minus 7 by 10. And on the other side also let's write all three minus 2 by 5 plus 4 by 15 plus minus 7 by 10. Now let's group them. So here we are grouping the second and the third. Second one and the third one, that is these two rational numbers. Here we are grouping the first and the second. Now we are going to prove this. Now this is the left hand side. This is the right hand side. We are going to prove that both are equal. So let's begin with the left hand side. So the left hand side will be minus 2 by 5 plus, okay, now here what do we have within brackets? 4 by 15 plus minus 7 by 10. That means the denominators are different, so we must find their LCM. So let's find the LCM of 15 and 10. Let's use 5. 5 threes are 15, 5 twos are 10. Now we can use 2 to bring down 3, 2 ones are 2. You can use 3 now, 1 and 1. So your LCM is 5 into 2 into 3. 5 twos are 10, 10 threes are 30. So that is our LCM that we are going to use here. So the denominator is now become common to both. So that is your LCM, 30. Now here 4 by 15 plus minus 7 by 10, we're going to convert it to denominators that have 30. Okay, so now we'll use the second method to find the numerator. So I'm going to take the first rational number 4 by 15 and I'm going to multiply it with the LCM, which is 30. Okay, now I'm going to cancel 15 and 30. 15 twos are 30, multiply the numerators, 4 twos are 8. Now this 8 I'm going to write here as the numerator. This is the second method that I'm using. You can use whichever method is easier for you. Now I'm going to take the second rational number minus 7 by 10 and write it just like this. So that is going to be minus 7 by 10. I'm going to multiply it with the LCM, 30. Now cancel 10 and 30. 10 threes are 30. Now multiply the numerators. Minus 7 into 3 is minus 21, which I can write here minus 21. So this is another way of getting the numerators. So now let's continue. This is minus 2 by 5 plus, within brackets what do we have? 8 plus minus 21 means 8 minus 21 by 30. So this will remain as minus 2 by 5. Now the next one will be plus 8 minus 21. Signs are different, so we put the sign of the bigger number and we subtract. So it's minus 21 minus 8 is 13. 13 by 30. So here we have minus 2 by 5 plus minus 13 by 30. And we have to find the LCM of these two numbers, 5 and 30. So 5 and 30, let's find the LCM. We can use 5 itself. 5 ones are 5, 5 sixes are 30. Use 2 to bring down 1, 2 threes are 6. Now we can use 3, 1 and 1. So the LCM will be 5 into 2 into 3. 5 twos are 10, 10 threes are 30. So this is our LCM which we are going to use here. So this is 30. Now let's take the first rational number minus 2 by 5, multiply it with the LCM. Cancel 5 and 30. 5 sixes are 30. Multiply these two. It becomes minus 12. So let's write there minus 12 plus. Look at the second rational number minus 13 by 30. The denominator is the same. So we can write the same numerator also. So that's minus 13. So this is now equal to minus 12 minus 13 by 30. So here you can see minus 12 minus 13 signs are the same. So we put the same sign and we add 12 plus 13 is 25. Minus 25 by 30. This is the answer that we have got here on the left hand side. Now we are going to work out the right hand side and see what answer we are getting. So this time remember the grouping is different. We have grouped the first and the second rational numbers. After adding this, we add the third rational number. So what we're working now is on the right hand side. So on the right hand side, we have these two numbers. So let's begin that. So to simplify this, the denominators are different. So we should find the LCM of 5 and 15. So let's do that. 5 and 15. Let's find the LCM. Begin with 5. 5 ones are 5. 5 threes are 15. Continue with 3, 1 and 1. So what is our LCM? Our LCM is 5 into 3. 5 threes are 15. So this is our LCM. So let's use that. So here we're going to write 15. And we're going to take the first rational number. Our first rational number is minus 2 by 5. We're going to multiply it with 15. So minus 2 by 5. Multiply this with the LCM which is 15. Cancel 5 and 15. 5 threes are 15. Multiply these two. So it becomes minus 6 which we can write here minus 6. Plus, now look at the second rational number. The denominator is the same, 15 and 15 here, isn't it? So we can write the same numerator, which is 4. So we write 4 here and we close the bracket. We continue with the addition of plus minus 7 by 10. So let's work out what's within brackets. Now here we have minus 6 plus 4. Signs are different, so we can put the sign of the bigger number and subtract. So that becomes minus 2 by 15. And here we have plus minus 7 by 10. Now here we can simplify this. We have to find out the LCM of 15 and 10. So let's do that. 15 and 10, the LCM. Let's begin with 5. 5 threes are 15. 5 twos are 10. Continue with 3. 3, 1 and then you have 2. Continue with 2, 1 and 1. So what is our LCM? That is 5 into 3 into 2. 5 threes are 15. 15 twos are 30. 30 is the LCM which we are going to use as the common denominator here, 30. Now let's look at our first rational number, minus 2 by 15. So let's take that minus 2 by 15 and multiply it with the LCM which is 30. And now cancel 15 and 30. 15 twos are 30. Multiply these two. 2 twos are 4 minus 4. Plus, take the second rational number which is minus 7 by 10. Multiply it with the LCM 30. Cancel. 10 ones are 10. 10 threes are 30. Multiply these two. This is 7 threes are 21. So let's write that minus 21. Now let's remove the brackets. Minus 4 minus 21 by 30. Here the signs are the same. So we put the same sign and we add. So this becomes minus 21 plus 4 is 25. 25 by 30. So on the right hand side when we added we got minus 25 by 30. On the left hand side we have minus 25 by 30. What does this mean? That the left hand side is equal to the right hand side and we have verified the associative property for this set of rational numbers. So let's write that left hand side is equal to right hand side, hence verified. Question 3, here also we're going to verify the associative property. So let's write down all three rational numbers. Minus 7 by 9 plus 2 by minus 3 plus minus 5 by 18. This is the left hand side. Right hand side also, let's write the same. Minus 7 by 9 plus 2 by minus 3 plus minus 5 by 18. Now the grouping is going to be different. Now we're going to group the second and the third ones here. Here let's group the first and the seconds. And we're going to prove that however you group it, your answers on both sides will be the same. So this is the left hand side, this is the right hand side. Let's begin with the left hand side. So here we are writing the first rational number as it is, minus 7 by 9 plus. Now we are going to work out what is inside. So for this, can you see that this rational number, in this rational number, the denominator is negative. So we are going to move this negative to the numerator. Now I hope all of you remember how we are able to remove this negative sign. Now let me show that to you once again. Now suppose you have the same rational number, minus 3, and if we have to make this positive and remove this minus sign from here, we have to multiply this with another negative number and still not change that 3. So if we multiply this with minus 1, what will you get? Minus 3 into minus 1. Minus into minus is plus. 3 ones are 3. Now can you see that this negative 3 has now become positive 3. So when you multiply this with a minus 1, you have to multiply the numerator also with minus 1. So we write into minus 1 here. So here when you multiply 2 into minus 1, you get minus 2. So this is how we move the negative sign from the denominator here to the numerator. So you have to remember this. This is how it is actually done. So now let's straight away write that here. We don't have to work out all this each time. So that will be minus 2 by 3 plus the other side it's already minus 5 by 18. So now we are going to simplify this. Here as you can see denominators are different, so we need to find the LCM. This one remains the same in the beginning. So here this is minus 7 by 9 plus, now let's work out the LCM of 3 and 18. So begin with 3. 3 ones are 3. 3 sixes are 18. Continue with 3. 3 ones are 3. 3 twos are 6. Now you can use 2, 1 and 1. So our LCM will be 3 into 3 into 2. 3 threes are 9. 9 twos are 18. So the LCM is 18. So here we're going to use this 18 and get the new numerators. For that, let's take the first rational number, which is minus 2 by 3, and multiply this with the LCM, which is 18. Now cancel. 3 sixes are 18. Multiply these two. 6 twos are 12 minus 12. So that will be the new numerator, minus 12 plus. Take the second one. Look at the second one. The denominator is the same, 18 and 18. So we can write the same numerator also, minus 5. Okay, so now let's remove the brackets. So this becomes minus 7 by 9 plus minus 12. Now this is within brackets. Minus 12 minus 5 by 18. So this is minus 7 by 9. Now here, look at this. Minus 12 minus 5, signs are the same. We put the same sign and we add. 12 plus 5 is 17. Minus 17 by 18. So here now the denominators are 9 and 18 and the LCM will be 18. So let's use that. LCM is 18. Take the first rational number, minus 7 by 9, multiply it with 18, cancel 9 and 18, 9 twos are 18, multiply minus 7 into 2 is minus 14. So let's write minus 14 here and look at the second rational number, minus 17 by 18. 18 is the same, so we can write the same numerator also, which is minus 17. Now here signs are the same, so put the same sign and add. Here 14 plus 17 is 31 and in the denominator we have 18. So what is our answer here? Minus 31 by 18 on the left hand side. Now let's work out the right hand side. This is the right hand side. Let's work out that. Now here again we're going to work out what is inside here. So let's write down this. Now, as you can see here, the denominator is negative. So we're going to move that negative sign to the numerator. So let's write that. Minus 7 by 9 plus minus 2 by 3 plus minus 5 by 18. So now we need to work out what is within brackets here. And as you can see, denominators are different. So we must find the LCM of 9 and 3. The LCM of 9 and 3 will be 3 itself. So let's write, will be 9. Will be 9. So look at the first rational number, minus 7 by 9. The denominator is 9. It's the same. So we write the same numerator also, minus 7. Now look at the second rational number, it's minus 2 by 3. So let's take that here, minus 2 by 3 and multiply it with the LCM which is 9. Cancel 3 and 9. So 3 ones are 3, 3 threes are 9. Multiply these two, minus 2 into 3 is minus 6. So we can write that here. So this is minus 6 plus minus 5 by 18. Now, if you have to work out what's within brackets here, let's open the brackets here. Minus 7 minus 6 by 9 plus minus 5 by 18. So this becomes minus 7 minus 6. Signs are the same. So we put the same sign and we add 7 plus 6 is 13. So 13 by 9 plus minus 5 by 18. So here, as you can see, the denominators are different. We have to find the LCM of the denominators 9 and 18. So the LCM will be 18 in this case. 18. Now look at the first rational number, minus 13 by 9. Let's take that. Minus 13 by 9 and multiply it with the LCM which is 18. Now cancel 9 and 18. 9 twos are 18. Multiply this. 13 into 2 is 26 with a minus sign there. So that becomes minus 26. Now look at the second one here. The second rational number, denominator is 18. It's the same. So we can write the same numerator also, minus 5. So this is now minus 26 minus 5 by 18. Signs are the same. Put the same sign and add. 26 plus 5 is 31 and the denominator is 18. So on the right hand side, what have we got? We've got minus 31 by 18. And on the left hand side also we have minus 31 by 18. That means left hand side is equal to the right hand side. Hence we have verified the associative property of addition for this set of rational numbers also. Question 4, here also we have three rational numbers. Let's write them all down. Minus 1 plus 5 by 6 plus minus 2 by 3. This is the left hand side. Let's write the same 3 on the right hand side. Minus 1 plus 5 by 6 plus minus 2 by 3. Only the grouping is going to be different. Here we are grouping the second and the third rational numbers. On the right hand side, we are grouping the first and the second rational numbers. We are doing this to verify the associative property, which says that whichever way you group for addition, your answer is going to be the same. So this is the left hand side, this is the right hand side. Let's begin with the left hand side. So here minus 1 will remain the same plus, now inside brackets we have 5 by 6 plus minus 2 by 3. This has to be worked out. Here the denominators are different, so we have to find the LCM of the denominators 6 and 3. The LCM will be 6. So let's write that. The LCM is 6. Now look at the first rational number. It is 5 by 6. The denominator is the same as the LCM. That means you can write the same numerator 5. So let's write 5 there. So that is 5 plus. Look at the second rational number. It's minus 2 by 3. Take it here and multiply this with the LCM. Cancel 3 and 6. 3 2s are 6. Multiply these two. Minus 2 into 2 is minus 4. So let's write that. So this is plus minus 4. Close brackets. Then we continue. This is minus 1 plus 5 minus 4 by 6. So this will be minus 1. 5 minus 4 is 1. So that is plus 1 by 6. Now look at this one. This is just minus 1. And if we have to add it to this, let's give this the denominator 1. Minus 1 by 1. Now we have to find the LCM of 1 and 6. So the LCM will be 6. So let's do that. So this is 6. And here we can say 1 into 6 is 6. So multiply this also by 6. Minus 1 into 6 is minus 6. Look at the second rational number. The denominator is already 6. So we can write the same numerator. So that is plus 1. So here minus 6 plus 1, signs are different. Put the sign of the bigger number and subtract. 6 minus 1 is 5 and the denominator is 6. So what do we have here? Minus 5 by 6 on the left hand side. This is the answer. Now let's look at the right hand side. So here we can see minus 1 plus 5 by 6. So this one here itself we can give it a denominator 1. Now look at the denominators 1 and 6. So the LCM will be 6. Now look at the first one. 1 into 6 is 6. So multiply this also by 6. Minus 1 into 6 is minus 6 plus second rational number, the denominator is already 6, so we can write the same numerator, that is 5. To this we are going to add minus 2 by 3. So here let's work out minus 6 plus 5. Signs are different, so let's put the sign of the bigger number and subtract. So it's minus 1 by 6, and on the other side we have plus minus 2 by 3. Now we're going to find the LCM of the denominator 6 and 3, and the LCM is 6. Look at the first rational number, minus 1 by 6. The denominator is the same, so we write the same numerator, minus 1. Take the second rational number, that is minus 2 by 3. Multiply it by the LCM 6. Cancel 3 and 6. 3 2s are 6. Multiply these two. Minus 2 into 2 is minus 4. So we can write that here, minus 4. Now let's remove the brackets. It becomes minus 1 minus 4 by 6. Signs are the same. Minus 1 minus 4. So add it up. Put the same sign and add. 4 plus 1 is 5 by 6. So on the right hand side our answer is minus 5 by 6. On the left hand side too we got minus 5 by 6. That means left hand side is equal to right hand side and we have verified it. Question 6. Write the additive inverse of all these rational numbers given here. Now what is the additive inverse? First you should know what is the additive identity. The additive identity for rational numbers is 0. That means any number. Now suppose I take a rational number 2 by 3. Any number that I add to this should give me back the original number 2 by 3. Now what can I add to 2 by 3 so that I get back 2 by 3? I can only add 0, isn't it? So 0 is called the additive identity for all rational numbers. Now what is the additive inverse? Additive inverse is the number which when added to the original number gives 0. That is, if I take the number 2 by 3, now what should I add to this to get 0 as my answer? Now this 2 by 3 is a positive number. If I add the negative of this minus 2 by 3, let's see what we get. Okay, so the LCM is 3. Then the numerators remain the same. 2 plus minus 2, which is equal to 2 minus 2 by 3. 2 minus 2 is 0. 0 by 3 is equal to 0. So what do we see here? We see that to an original number, if you add, now this is a positive number, if you add a negative number of that, you get 0. That means if you have a negative number, if you add positive of it, then you get 0. So that is called the additive inverse. So if the number is negative, you write the positive of that number. If the number is positive, you write the negative of that number. So let's begin with the first one. Let's write the additive inverse of minus 3 by 8. As you can see, minus 3 by 8 is a negative number. So the answer should be positive 3 by 8. This is our answer. It's very simple. Now the next one, the additive inverse of 4 by minus 9. Now you know the denominator is negative. So this becomes minus 4 by 9. This is a negative number. So the additive inverse will be positive 4 by 9. So let's circle the additive inverse. So here it is 3 by 8. Here it is 4 by 9. Third one, the additive inverse of minus 7 by 5. This is a negative number. So that's going to become positive 7 by 5. So if it is negative, the additive inverse will be positive. Now here the additive inverse of minus 4 by minus 13. The fourth one is minus 4 by minus 13. So here you should be careful. There are two minus signs, numerator and denominator, which will get cancelled. So now this is 4 by 13. So what is the additive inverse of 4 by 13? That's a positive number. So the answer will be negative minus 4 by 13. So this is our answer, minus 4 by 13. So here you should be careful when you see questions like this. Next one, the additive inverse of the fifth one, which is 0. The additive inverse of 0 is always 0 itself. Next one, the additive inverse of minus 2 will be positive. So that is 2. Question 7. The additive inverse of 1. So 1 is positive. So the additive inverse will become negative, minus 1. Next one, the additive inverse of the eighth one is minus 1 by 3 is the eighth one. It's negative. So now this becomes positive 1 by 3. And the last one, the additive inverse of minus 3 by 1 will become plus 3 by 1 or 3 by 1. So these that are circled here in red are the additive inverse of these sums, these rational numbers. Question 7, fill in the blanks. Now in the new book, this will be question number 8. The additive inverse of minus 5 by minus 12. What will that be? Now we have learnt about additive inverses. Now here minus 5 by minus 12, we can cancel the minus sign. So we have 5 by 12. So the additive inverse of a positive number, rational number, will be a negative number. So now this has become 5 by 12 and the additive inverse will be minus 5 by 12. Question 2, minus 5 by minus 12 plus its additive inverse. Now additive inverse is this. So this plus this is equal to 0. Okay, that's why it's called the additive inverse. When you add up a number, a rational number and its additive inverse, your answer will be 0. If A by B is the additive inverse of minus C by D, then minus C by D is the additive inverse of A by B. Okay, this is the first part. Then A by B plus minus C by D, that is A by B is the additive inverse of this. So you have a rational number and its additive inverse. When you add up a rational number and its additive inverse, what do you get? You get a 0. This is equal to, again, the additive inverse and a number, when you add it up, you get 0. So 0 and 0 here, your answer will be 0. Question 8. State true or false. First statement. Here it says 7 by 9 is equal to 7 plus 5 by 9 plus 5. That is, if we take this rational number and add 5 to the numerator and denominator, does it become equal to this? That is a statement. We should write true or false. If it's equal to this, we say true. If it is not equal, we say false. So we have to work out this part. 7 plus 5 is 12 and 9 plus 5 is 14. So we've got 12 by 14. Let's reduce this to the lowest term. You can divide both by 2. 2 6s are 12, 2 7s are 14. So what is the rational number that we have got now? What we've got is 6 over 7, 6 by 7. Whereas here we have 7 by 9. So 7 by 9 is not equal to 6 by 7 as the statement says. So this statement is false. Next one, 7 by 9 is equal to 7 minus 5 by 9 minus 5. So the statement says that if we take the same rational number and take away 5 from the numerator and denominator, both will be equal. The left hand side and the right hand side will be equal. So let's work out the right hand side and see now. So this, let's see, 7 minus 5 is 2 and 9 minus 5 is 4. Let's reduce this to the lowest term. 2 1s are 2, 2 2s are 4. So what is the new rational number that we have? 1 by 2. Whereas here we have 7 by 9. So 7 by 9, the statement says is equal to 1 by 2, which is wrong, and the statement is false. Third one, 7 by 9 is equal to 7 by 9 into 5 in the numerator and into 5 in the denominator. So when we multiply by 5, do we get this back? Let's see. 7 fives are 35, 9 fives are 45. Now reduce both to the lowest term, divide both by 5. 5 sevens are 35, 5 nines are 45. So what's the rational number that we have now? We have 7 by 9. So here we have 7 by 9 and here we have 7 by 9. That means this statement is true. Question 4. 7 by 9 is equal to 7 divided by 5 and 9 divided by 5. So let's work this out and see. So this will be 7 divided by 5 divided by 9 by 5. So how do we write this? We write this as 7 by 5. Now when you take this 9 by 5 to the top there, you write the reciprocal of this. So 9 by 5 becomes 5 by 9 and it changes to multiplication into 5 by 9. Now here we can cancel 5 and 5 and what is left is just 7 by 9. So what is left is 7 by 9. So the question is 7 by 9 and this is equal to 7 by 9. So this statement is true. Question 5. Minus 5 by minus 12 is a negative rational number. Is that true or false? Now let's take minus 5 by minus 12. Now since there is a minus sign in the numerator and denominator, we can cancel it. So what is the rational number that we have now? 5 by 12, which is a positive rational number. So this statement says this is a negative rational number, which is false. So this statement is false. Question 6. Minus 13 by 25 is smaller than minus 25 by 13. Now to find out if this is smaller than this, we have to compare them. Now how do we compare rational numbers? Now we have minus 13 by 25 and we have minus 25 by 13. Now there are two ways of comparing numbers like this, fractions or rational numbers. One way is to find the LCM and do it, otherwise you cross multiply. So here let's cross multiply these. Okay, so minus 13 into 13 is minus 13 into 13 is 169. Now cross multiply 25 and minus 25. So we have minus 25 into 25 is 625. Now in this we have minus 169 and minus 625. Which one is smaller or which one is greater? We have to compare. Now remember your integers. Now suppose this is an integers number line. This will go on endlessly on both sides, isn't it? Then we have 0 and on the right side we have all the positive numbers. So this goes on and on the left side we have all the negative numbers. So minus 1, minus 2, this goes on and on. Now here we have minus 169. So that will come first. Minus 169 will come first and then only we have minus 625. Now as you keep moving to the left, the numbers become smaller and smaller. So here you have 625 here and 169 here. Both are negative numbers. So as you keep going to the left, it becomes smaller. That means this is smaller than this. So 169 is actually minus 169 is greater than minus 625. So here the question is minus 13 by 25, which is this, is smaller than minus 25 by 13, which is this, and this statement is false. So this now is question 8 in the old book. In the new book, this is question 9. Question 10 has been added in the new book. So let's do this. The weight of an empty fruit basket. So they're talking about a fruit basket which is empty, it doesn't have any fruits, and that weight is 1 by 3 kgs. Now if it contains so many kgs of grapes and so much of mangoes, we need to find the total weight of the basket with fruits. So first we have an empty fruit basket, then the basket is filled with fruits. So now we have to find the total weight of the basket with fruits. So this is a word problem. So we normally have word statements. So weight of an empty fruit basket is 1 by 3 kg. This is given to us. Weight of the grapes is so much, which is given to us 5 by 6 kilograms. And then weight of mangoes is 3 by 8 kilograms. Now to find the total weight of the basket with fruits, what should we do? We should add up all this. We should add up the weight of the empty fruit basket and the weight of grapes and mangoes. So let's do that. So to find the total weight, we're going to add this up. Now these are all mixed numbers. So let's do this addition. So first thing, we're going to convert the mixed numbers into improper fractions. Now I hope all of you remember how to do that. That is 3 2s are 6 plus 1, that is 7. So this becomes 7 by 3 plus, now this is 6 5s are 30 plus 5 is 35. So that becomes 35 by 6. Then the next one, 8 3 by 8, 8 8s are 64 plus 3 is 67. So this becomes plus 67 by 8. Now let me write it in this end here. So now we're going to add up these three rational numbers. As you can see, denominators are different, so we must find the LCM of the denominators. Now let's do that. Take the denominators 3, 6 and 8. Let's find the LCM. Let's begin with 2. So bring down 3. 2 3s are 6, 2 4s are 8. Continue again with 2. So you bring down the 3s as it is. 2 2s are 4. Continue again with 2. Bring down the 3s. 2 1s are 2. Now continue with 3. 3 1s are 3, 3 1s are 3. Now let's find the LCM. LCM will be 2 into 2 into 2 into 3. 2 2s are 4, 4 2s are 8, 8 3s are 24. So the LCM is 24. So let's use that LCM here to find the new numerators. Now we can use any method. You can use this, you can convert this into 24 and multiply, or we'll do the other method which is easier. 7 by 3, let's take the first rational number 7 by 3, multiply it by the LCM which is 24. Cancel, 3 8s are 24. Now multiply 7 8s are 56. So the first numerator here is 56 plus, let's go to the second rational number which is 35 by 6. So let's take that 35 by 6 and multiply this with the LCM. Now cancel, 6 4s are 24. Now multiply 35 into 4, it's 140. So let's write that 140. Let's take the third rational number which is 67 by 8. So we're going to write that 67 by 8 and we're going to multiply it with the LCM which is 24. Cancel, 8 3s are 24. Now if you multiply 67 into 3, you get 201. So let's write that here. So this is 201. So now we have the three numerators. Let's add up these three numerators. So when you add up all three, you get 397 as a numerator, and in the denominator we have 24. Now let's divide 397 by 24. So let's do that here. 397 divided by 24. So let's take 39. So 24 ones are 24 minus 5 you bring down, and then 3 minus 2 is 1. 157. So to get a number close to that, 24 into 6. 24 into 6 is 144. So let's minus 7 minus 4 is 3. 5 minus 4 is 1. So here if you write this as a mixed number, you will get 16. 13 by 24. So let's write it here. So this is 16, 13 by 24. And what is this? This is the total weight of the basket with fruits. So you have to write the unit which is kilograms. So we have found the answer to this question. What was the question? Find the total weight of the basket with fruits. So we have found the total weight of the basket with fruits, and that is 16, 13 by 24 kgs. So with this children, we come to the end of this exercise. Thank you children.